Hello dear viewers, welcome to TV Math Hub. In our today's session, we shall be looking at question number 7 of the WENSSEC mock. The question number 7 is given as, we are given that x is equal to a into t squared minus 1, y is given as 2a into t plus 1. These are the parametric equations of a given curve. We need to find the y dx and the 2y the x squared in terms of t. It is taking 5 marks. So let us look at how best we can obtain these 5 marks, and that will bring us to our solution. So given x in terms of a and t, y in terms of a and t, we shall remember that y and x are given in terms of a and t, but a will be treated as a constant and t is our variable. So for that case, if t is varying, then we can have our solution as. So we are given x as, we can try to simplify this and have this as at squared minus a. So if we are given x and we need the y dx, so we can easily get the x dt since x and t are our variables. So for this case, we shall have this as dx dt. So we shall try to differentiate on both sides with respect to t. And this will be same as differentiating also on this side with respect to t. So you are differentiating at squared minus a. So differentiating this is same as differentiating each of the individual terms. Is same as differentiating at squared, and is also same as differentiating with respect to t a. When you differentiate at squared, remember our a is a constant, so you will be differentiating t squared. To differentiate t squared, if you are differentiating t squared with respect to t, then you simply drop the power, reduce the power by 1, and this will give us 2t. So for that case, we shall have this as 2at minus, you are differentiating a constant with respect to t. So when you are differentiating a constant, you get 0. So this will give us 2at. So it implies that getting dx dt will be same as 2at. So that is the x dt. So to get the y dx, since we are given x in terms of t and y in terms of t, we shall first of all get the x dt, then the y dt, and we shall be in position to get the y dx. So let us look at y. Y is 2at plus 2a. When you try to simplify this, then we can now differentiate on both sides with respect to t. So differentiate this with respect to t, then differentiate also on your right hand side with respect to t. So when you do this, it is same as differentiating each of the individual terms with respect to t. So you are also differentiating this with respect to t. So if we do that, when you differentiate this, 2a is a constant, so you are differentiating t with respect to t, and that will be 1. So you will remain with 2a times 1. Then this is differentiating a constant term, which is 0. So this will give us 2a. So this will be your dy dt. So your dy dt is that, your dx dt is that. So how best can we get the dy dx? So the y dx will be given as the y dt times dt dx. When you look at this expression, the two expressions are equal because this dt and this can cancel out, and you have the y dx, which is equal to the y dx. So if you are looking at this, don't get the y dt, then you multiply by dt dx. If you get the y dt, you multiply by dx dt. When you do this, this one will be something different. So when you do this, it will be not equal to dy dx. So this is wrong. So we have dy dx as dy dt times dt dx. You already have your dy dt. Your dy dt is 2a. Then your dt dx, because you got dx dt, this is same as having 1 divided by dx dt. So in other words, dt dx. dt dx is the reciprocal of dx dt. Okay? So for that case, this is same as having 2a times 1 divided by dx dt, which is 2at. And this will be same as, so try to simplify this. this will give us 1 out of t. So this will be the dy dx. So dy dx is same as 1 out of t, and that will be your answer for dy dx. So let us look at d2y dx squared. Now d2y dx squared will be obtained by differentiating with respect to t dy dx, then you multiply by dt dx. This is how we obtain the 2y dx squared. We shall be differentiating dy dx with respect to t. You have to take note of that. The reason is, when you look at the dy dx we have is in terms of the parameter t. So if you have dy dx in terms of t, then to get the 2y dx squared, you will first of all differentiate this expression with respect to t, because it is in terms of t. Then after doing that, you will now multiply by the t dx. Remember, the two expressions must be equal. So when you look at this expression, this t and this dt can cancel out. Then you remain with d times dy, which is d2y, then dx times dx, which is dx squared. So if you are to get the 2y dx squared, make sure you first differentiate with respect to the variable that you are having, then multiply by dt dx. So that is what we shall do. So if that is what we need, what is dy dx? So we already have a dy dx as 1 upon t, and then we are multiplying by dt dx. As I said, dt dx is same as 1 upon dx dt. So we already have dx dt, so we shall substitute for that. So this will be d dt of t to power negative 1. So this is 1 upon t, which can be written as t to power negative 1, then times 1 upon dx dt. So what is dx dt? Dx dt is 2at. So we shall substitute here 2at. So this will give us, now differentiate this given expression with respect to t. Drop the power, negative 1, then multiply by this t raised to the power of negative 1, subtract 1. Okay, that is how we differentiate. Drop the power, reduce the power by 1. But this, you can do it at once. So this is times 1 upon 280. So this will give us negative 1 times t to power negative 2, then times 1 upon 280. So of course, this will be negative 1 upon this one here will be t squared times 1 upon 2at. So finally, we shall be able to obtain the 2y dx squared as negative 1 upon 2at to power 3. And this will be our answer.